Hey, this is Mr. Mitchell with a video on waves. You can tell I'm at school when I'm making this. Anyway, waves are a repeated disturbance that transfers energy, and these disturbances are started by a vibration. Here you have some kind of vibration that is going through this water. That is a disturbance. It is disturbing the water. It is repeated because you keep seeing these waves of energy go through, and they're going through a medium. A medium is matter through which a wave travels. Now, every wave doesn't have to have a medium, but some waves do have a medium. For example, you can see solids, liquids, and gases. That's where a medium can go through. Hey, come on in. I happen to be making a video here. You want to say something for the video? I guess that's a no. But anyway, this medium has solids, liquids, and gases which it can go through. And there are some waves that do need a medium. Now, all waves, whether they need a medium or not, are going to have wavelength and frequency. I'm sure you learned this in the 8th grade, where the wavelength is like crest to crest and trough to trough. And the frequency is how often you have these tops of the crest or bottoms of the trough. You can see in this example here, you have high frequency, you have the wave that is going quite fast, and that means you have low wavelength. And then if you have low frequency, then you have a really long wavelength, but it doesn't go up and down as fast. You don't have as much of a disturbance there. Now, what we're going to be talking about today is energy in these waves. Now, there are two primary types of waves that we will be discussing: mechanical waves and electromagnetic waves. A mechanical wave are the ones that do need a medium. It has to go through some kind of solid, through some kind of liquid, or through some kind of gas. Electromagnetic waves do not have to have that, and you can see some examples of those are light. Now, you have probably seen about longitudinal and transverse waves. The longitudinals look like a slinky whenever you'd have a diagram of them, and the transverse looks like a rope that you'd go up and down with when you have a diagram of them. But I want to talk about how the energy is in a mechanical wave and electromagnetic wave. So first, mechanical wave. To find out about energy in a mechanical wave, you have to see its amplitude. An amplitude measures the size of the disturbance of the wave. So whenever you have one of these transverse waves down here, the higher the line, the higher the amplitude. And when you have a higher amplitude, you have a bigger disturbance and more energy in the wave. So I think we had some waves back in this slide before. Here, even though one has low frequency and one has high frequency, you still have about the same size amplitude. That is from the middle to the top or from the middle to the bottom. So they would carry about the same amount of energy, even though they have different frequencies and wavelengths. With a longitudinal wave, the denser these compressions, the greater disturbance in the wave. So for a transverse wave, it's the higher the amplitude, the more disturbance or energy. For longitudinal waves, it is the more dense of these compressions, the more energy that you have. So that's kind of a distinction between those two. What about an electromagnetic wave? An electromagnetic wave is a wave made by vibrating electronic charges and composed of changing electronic and magnetic fields. In other words, it does not require a medium like solids, liquids, or gases. It uses magnetic fields and electric fields. Light, for example, does not go through any matter as it goes through space, but it goes through the electrical and the magnetic fields that are in space. So in this case, instead of transferring from particle to particle, they're transferred between these particular fields. So they exist where matter does not have to exist. So electromagnetic waves still have wavelengths and frequencies, and you might or might not can see that there's a top of a wave and top of a wave, and of course it would have a frequency. The closer the wavelength, the higher the temperature, and the higher the frequency, the higher the energy. So the closer these wavelengths are together, the higher the temperature, the higher the frequency, the higher the energy. So that would be what determines energy in an electromagnetic wave. So we have three energies here. We have the energy in a transverse wave, which is measured by its amplitude. The higher or the lower, then you have more energy. In these longitudinal waves, it's the denseness of these compressions. The ones that are more dense are the ones that are going to have more energy. And then the electromagnetic waves, the closer the wavelengths are, the higher the frequency, the higher the energy, and that's also the higher the temperature. Now these electromagnetic waves, they are going to be interacting with other objects to make other objects gain energy. For example, light from the sun may hit on the asphalt, and the asphalt will then heat up because of its interaction. So electromagnetic waves can cause other things to have a lot of energy also. Well, I hope you have learned a little bit about waves and how you get energy from these different kinds of waves. Hope you learned something.